November 8, 1942. Major General Wilhelm von Thoma's gloved hand rested on the warm armor plating of the abandoned American vehicle as smoke from the burning British tanks still drifted across the desert floor near El Alamein. The half-track, that's what the Americans called it, sat motionless in the sand, its engines silent but intact, crew nowhere to be found. Von Thoma had seen photographs in intelligence briefings, grainy images accompanied by dismissive reports that described American half-tracks as improvised transport vehicles of limited military value. But standing here, examining the vehicle up close for the first time, something felt wrong. The construction quality, the automotive components, the weapon mounts, everything contradicted what Berlin had told them to expect. Von Thoma signaled to Hauptmann Ernst Becker, his technical liaison officer, to bring the examination team forward. What they would discover over the next 72 hours would force a complete reassessment of American industrial capabilities, strategic intentions, and most devastatingly, Germany's own chances of victory in a war that was increasingly being decided not by tactical brilliance, but by factory output measured in tens of thousands of units. The half-track sitting in the Egyptian desert was serial number 4847 of a production run that German intelligence estimated at perhaps 3,000 vehicles. The actual number, which von Thoma's team would eventually uncover, was so staggering that his initial reports to Berlin were returned with demands for verification, as if he had made a clerical error. He had not. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Battle of El Alamein had ended badly for the Afrika Korps. Field Marshal Erwin Rommel's forces, exhausted after 2 years of desert warfare, had finally been broken by Bernard Montgomery's methodical assault supported by overwhelming material superiority. As German and Italian forces retreated westward toward Libya, they left behind a battlefield littered with destroyed vehicles, abandoned equipment, and critically for military intelligence intact examples of Allied equipment that had never before fallen into German hands. Major General Wilhelm von Thoma had not retreated with the main force. Surrounded by British armour on November 4th, he had been captured after his command tank was disabled. But before his capture, he had ordered his technical staff to catalogue and preserve any captured enemy equipment, particularly American material, which was appearing in North Africa in increasing quantities. Hauptmann Ernst Becker, 31 years old, former automotive engineer at Daimler-Benz, now found himself leading a small technical intelligence detachment operating behind German lines as the Afrika Korps withdrew. His orders were explicit: capture American equipment intact, document everything, and ship the most significant examples back to testing facilities in Germany for detailed examination. On November 8th, Becker's team discovered what would become the most important intelligence find of his career. East of El Alamein, in an area recently abandoned by American forces attached to the British 8th Army, they found 6 M3 half-track personnel carriers. 4 had been destroyed by artillery fire or deliberately sabotaged. 2 were intact, apparently abandoned when their crews were killed or forced to withdraw suddenly. Becker approached the first intact half-track cautiously. American equipment was notorious for booby traps, a lesson learned painfully in Tunisia when a seemingly abandoned jeep exploded, killing 2 German soldiers. But this half-track showed no signs of tampering. The crew had left in a hurry. Personal items remained in the cargo compartment: canteens, ammunition pouches, a magazine showing smiling American women in swimming, costumes. The vehicle itself was unlike anything Becker had seen in German service. The front portion rode on conventional wheels with pneumatic tires, while the rear was supported by tracked assemblies that gave the vehicle mobility across soft sand and rough terrain. The body was armoured not heavily, but enough to stop rifle fire and shell fragments. Caliber machine gun was mounted on a pedestal near the commander's position. Becker climbed into the driver's seat. The interior was spacious, well laid out, with controls that seemed almost civilian in their simplicity. The steering wheel was a standard automotive type, not the complex steering levers required for fully tracked vehicles. The dashboard held conventional gauges, speedometer, fuel, oil pressure, temperature, all clearly marked in English with simple graphics that required no language skills to understand. He examined the engine compartment. The power plant was a white 160AX, a six-cylinder gasoline engine producing 147 horsepower. Becker knew engines. He had spent 5 years at Daimler-Benz, designing truck motors for military contracts. This American engine was not revolutionary in design. It was a straightforward inline-six using proven technology that any competent manufacturer could produce. But it was the details that caught his attention. The engine was mounted on rubber isolators to reduce vibration. All major components were easily accessible for maintenance. The air filter was a replaceable cartridge type, no complex cleaning procedure required. The electrical system used a 12-volt generator, double the voltage of most German military vehicles, providing more reliable starting and brighter lights. The transmission was equally impressive. It was a 4-speed manual with a 2-speed transfer case, giving the vehicle 8 forward gears and 2 reverse. The shifting mechanism was smooth, synchronized luxury car technology applied to a military vehicle. German half-tracks used crash gearboxes that required double clutching and precise timing to prevent grinding gears. Becker spent 3 hours examining the first vehicle, taking notes, making sketches, photographing details with his Leica camera. Then he moved to the second intact half-track. It was identical to the first in every measurable way, not similar identical. The serial numbers were different, indicating these vehicles had been built weeks or months apart, possibly in different factories. Yet every component, every dimension, every part was interchangeable. This was not handcrafted military equipment where each vehicle had slight variations requiring individual adjustment. This was mass production precision engineering applied to a complex military vehicle. Becker had seen German half-tracks being assembled at Hanomag and Büsing NAG factories. Each vehicle required hundreds of hours of skilled labor, with craftsmen hand-fitting components, adjusting assemblies, and performing individual tuning. Production rates were measured in dozens per month. These American half-tracks revealed a completely different manufacturing philosophy. They were designed from the ground up for high-volume production by semi-skilled workers. Becker examined welded seams. They were uniform, consistent, clearly made by trained welders working from jigs and fixtures. Body panels were stamped steel, identical between vehicles, requiring no hand-forming or individual adjustment. The tracks themselves were a marvel of practical engineering. Each track assembly consisted of rubber blocks mounted on steel cables. The system was lighter and quieter than German all-metal tracks, required no lubrication, and could be repaired by replacing individual blocks rather than entire track sections. Most remarkably, the tracks appeared to be commercial products. Becker found a manufacturer's stamp indicating they were produced by the Firestone Tire and Rubber Company. The Americans were using tire manufacturers to produce track systems. They had transformed a specialized military component into a mass-produced item that could be manufactured by civilian industry. This implied production capacity and supply chain integration that Germany had never attempted. Over the next 2 days, Becker's team systematically documented both captured half-tracks. They measured every dimension, photographed every component, and recorded every serial number and manufacturer marking they could find. The data accumulated into a disturbing picture of American industrial organization. The vehicles were assembled from components produced by multiple manufacturers. The engine was built by White Motor Company. The transfer case was manufactured by Timken. The axles came from Eaton. The body was stamped by Autocar Company. The tracks were produced by Firestone. Each component bore clear identification markings with part numbers, specification codes, and manufacturing dates. This decentralized production system allowed the Americans to distribute manufacturing across dozens of factories. If one facility was destroyed or suffered production problems, others could increase output to compensate. The system was resilient, scalable, and most critically already operating at a scale that seemed impossible based on German intelligence estimates. Becker found a data plate riveted to the dashboard of the first half-track. It listed the vehicle designation M3A1, the contract number W398QM1553, the serial number 4847, and the manufacturing date August 1942. August 1942. This vehicle was only 3 months old. The second half-track bore serial number 4983, manufactured in September 1942. The sequential serial numbers suggested that at least 136 vehicles had been built between these two units in approximately 1 month. If that production rate was consistent, a single factory was producing over 1,500 half-tracks annually. But Becker knew from intelligence reports that multiple American companies were building half-tracks. How many factories were involved? What was the total production rate? He drafted his initial report to German intelligence on November 10, 1942. The report documented the technical specifications of the M3 half-track, included photographs and measurements, and concluded with an assessment that shocked even Becker himself as he wrote it. The captured American half-track represents a vehicle class that Germany does not possess in comparable quantity or production capacity, he wrote. The design prioritizes ease of manufacture, operational simplicity, and maintenance accessibility over technical sophistication. This philosophy allows production by semi-skilled workers using components from multiple manufacturers. Based on serial number analysis and component dating, estimated American production capacity exceeds 1,000 units monthly, possibly significantly higher. Recommend immediate assessment of total American half-track production and strategic implications for mechanized warfare. The report was transmitted to Oberkommando des Heeres, OKH, the German Army High Command, on November 12. It arrived at a moment of crisis. Rommel's Afrika Korps was in full retreat. The Americans had landed in Morocco and Algeria on November 8, Operation Torch, threatening German forces with encirclement. And on the Eastern Front, Soviet forces were about to launch Operation Uranus, the counter-offensive that would surround the German Sixth Army at Stalingrad. In this context, a report about American half-track production seemed almost trivial. Germany was facing strategic disaster on multiple fronts. What did it matter that the Americans had good armored personnel carriers? But at OKH's Technical Intelligence Section, Oberst Colonel Friedrich Paulus, no relation to the general commanding at Stalingrad, recognized the significance of Becker's report immediately. Paulus had spent the previous year trying to convince senior officers that American industrial capacity was being systematically underestimated. Reports about American aircraft production, tank manufacturing, and naval construction all suggested output levels far exceeding German intelligence estimates. The half-track report provided concrete evidence. These were not propaganda claims or inflated statistics. These were actual vehicles examined in detail by a qualified engineer. The serial numbers, component markings, and manufacturing dates told a story that could not be dismissed. Paulus ordered an immediate investigation. How many American half-tracks existed? Where were they being produced? What production rates were achievable? The answers, when they came, would force a complete reassessment of American military-industrial capabilities. Oberst Friedrich Paulus had access to resources that Hauptmann Becker in the desert could not tap. As head of Section 3, Technical Intelligence, at OKH, Paulus commanded a staff of 37 officers and analysts responsible for assessing enemy equipment and production capabilities. They maintained files on every known Allied weapons system, compiled from battlefield captures, intelligence reports, aerial reconnaissance, and signals intercepts. On November 15, 1942, Paulus convened an emergency assessment meeting. Present were his senior analysts, representatives from the Reich Ministry of Armaments, and liaison officers from German industrial firms, including Daimler-Benz, Hanomag, and Bussing NAG, the companies that produced Germany's own half-track vehicles. Paulus began the meeting by distributing copies of Becker's report from El Alamein, along with photographs of the captured M3 half-tracks. He gave the attendees 30 minutes to review the material, then asked for initial assessments. Oberstleutnant Hans Weber, specialist in armored vehicle production, spoke first. The vehicle design is conventional. Nothing we see here represents technology beyond German capabilities. The American half-track is actually less sophisticated than our SD, KFZ, 251. Their armor is thinner, the payload capacity is lower, and they use a wheeled front end rather than full tracks, which reduces cross-country mobility. Paulus nodded. Agreed. The vehicle is technically inferior to German designs, but what about the production implications? Weber hesitated. The serial numbers concern me. If Becker's analysis is correct, and these vehicles were built 1 month apart with 136 units between them, we're looking at monthly production exceeding 1,000 units. That would be more than our entire half-track production across all manufacturers. Major Heinrich Steiner, from the Ministry of Armaments, leaned forward. No single factory can produce 1,000 complex armored vehicles per month. Our best plants, Hanomag in Hanover, Bussing in Braunschweig, produce perhaps 60 to 80 vehicles monthly at peak capacity. The Americans would need a dozen factories to achieve the numbers you're suggesting. Then perhaps they have a dozen factories, Paulus replied quietly, or 2 dozen. The Americans have an automotive industry orders of magnitude larger than Germany's. Before the war, they produced over 4 million passenger cars annually. Their manufacturing infrastructure is continental in scale, if they've converted even a fraction of that capacity to military production. He let the sentence hang. The men around the table were engineers and production specialists. They understood the implications immediately. Germany's entire automotive industry produced approximately 300,000 vehicles annually before the war, including cars, trucks, and buses. American production was more than 10 times larger. If the United States had truly mobilized that industrial capacity for war production, the quantitative advantage would be insurmountable. We need hard data, Paulus said. Contact our agents in neutral countries. Query signals intelligence for any intercepts mentioning American vehicle production. Review all battlefield reports from North Africa for mentions of half-tracks, how many units are appearing, how frequently, what variations exist. I want a comprehensive assessment within 2 weeks. The investigation that followed would become one of the most thorough intelligence operations of the war. German agents in Switzerland, Sweden, Spain, and Portugal were activated to gather information about American industrial mobilization. They combed through American newspapers and trade publications, looking for any mention of military production. They interviewed refugees, neutral businessmen, and anyone else who might have information about American factories. Signals intelligence proved particularly valuable. German cryptographers had achieved limited success, breaking lower-level American military codes. While high-level strategic communications remained secure, tactical radio traffic often used simpler ciphers or even plain language. Monitoring stations in occupied France intercepted American radio communications from England, where US forces were assembling for future operations. By late November, the intercepts revealed something stunning. American units in England were reporting equipment inventories that included hundreds of half-tracks, not dozens, hundreds. A single armored division listed over 200 half-tracks in its table of organization. If America was fielding multiple armored divisions, each with similar equipment levels, total half-track production must be measured in thousands of units, not hundreds. Aerial reconnaissance provided additional evidence. Luftwaffe reconnaissance aircraft, operating at extreme range from bases in France, occasionally photographed American ports in England. Photos from Southampton in December 1942 showed dozens of half-tracks staged in marshalling yards awaiting distribution to combat units. The Americans were shipping these vehicles across the Atlantic in quantities that suggested truly massive production. But the most devastating evidence came from an unexpected source. American newspapers. Germany maintained subscriptions to major American publications through intermediaries in neutral countries. These papers arrived weeks or months late, but they provided invaluable intelligence about American morale, political debates, and crucially industrial production. In early December, an analyst reviewing October editions of American newspapers found an article in a Cleveland, Ohio publication celebrating the 10,000th half-track produced by the White Motor Company. The article included a photograph of workers posed around the vehicle, dated October 23, 1942, 10,000 units from one manufacturer, and the article mentioned that White was only one of several companies producing half-tracks for the U.S. military. Paulus immediately requested verification. Could this be propaganda? An inflated claim meant to boost morale? His analysts cross-referenced the Cleveland article with other sources. They found mentions in Detroit newspapers about Autocar Company producing half-tracks. A Philadelphia paper discussed production at the Diamond T Motor Company. Trade publications referenced contracts with International Harvester. The Americans weren't using one or two specialized military manufacturers. They had mobilized their entire truck industry. Companies that normally produced commercial vehicles were mass-producing military half-tracks using the same assembly line techniques that built civilian trucks and buses. By mid-December, Paulus had assembled enough evidence for a preliminary report. He titled it, Assessment of American Half-Track Production Capacity and Strategic Implications. The report ran to 47 pages, included dozens of photographs and intercepts, and reached conclusions that contradicted everything German military planning had assumed about American industrial capabilities. The key findings were devastating in their clarity. First, American half-track production was not centered on one or two military arsenals, but distributed across at least 5 major manufacturers: White Motor Company, Autocar Company, Diamond T, International Harvester, and several smaller firms. This decentralized system meant that production could scale rapidly and was resilient to disruption. Second, total American production already exceeded 10,000 units by October 1942, less than 1 year after the United States entered the war. Production rates were accelerating. The monthly output in October was estimated at 1,500 units, triple the rate from January 1942. Third, the Americans were organizing entire armored infantry battalions equipped with half-tracks. Each battalion required approximately 150 vehicles. With current production rates, America could equip one new armored infantry battalion every 3 days, for an entire year. Fourth, and this was the conclusion that Paulus knew would be rejected by senior commanders, American half-track production alone represented industrial capacity equal to Germany's entire armored vehicle production, including tanks, assault guns, and half-tracks combined. Paulus submitted his report to OKH on December 18, 1942. He marked it most secret and requested immediate distribution to the highest levels of military command, including the Wehrmacht Operations Staff and the Reich Ministry of Armaments. The response came back within 48 hours. The report was classified as unreliable speculation based on insufficient evidence. Senior officers noted that German forces had encountered relatively few American half-tracks in combat. If production was truly in the tens of thousands, where were all these vehicles? Paulus prepared a response, explaining that American forces in late 1942 consisted of only a few divisions actively engaged in combat, mostly in North Africa. Units still training in the United States or being positioned in England for future operations. Current battlefield observations showed only the leading edge of American deployment. Within 6 months, American forces would expand dramatically, and the equipment now being produced in massive quantities would flood battlefields across multiple theaters. His response was acknowledged but not acted upon. Germany's senior military leadership in December 1942 was focused on immediate crises: Stalingrad, North Africa, the Eastern Front. Long-term strategic assessments about American production capacity were filed away as interesting but not urgent. Oberst Friedrich Paulus returned to his office in Berlin and added one final note to his personal copy of the report. He wrote in the margin, "They will not believe until they see it with their own eyes. By then it will be too late." He was correct on both counts. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. January 23, 1943. General Major Hans Kramer stood in the morning cold outside Sfax, Tunisia, watching an endless column of American vehicles roll past his observation post. He had been counting for 20 minutes. Jeeps, trucks, half-tracks, more half-tracks, artillery tractors, tank transporters, and still more half-tracks. The column stretched to the horizon in both directions, a river of olive-drab metal flowing eastward toward the front lines. Kramer had commanded armored forces in Poland, France, and Russia. He understood mechanized warfare, logistics, and the mathematics of military mobility. What he was witnessing defied those mathematics. No army could sustain this level of mechanization. The fuel consumption alone would be impossible. The maintenance requirements would overwhelm any supply system. Yet here they were, thousands of vehicles moving with the casual efficiency of a Berlin tram system. He turned to his aide, Lieutenant Otto Fischer, who had been recording vehicle types and quantities. "How many half-tracks so far?" Fischer consulted his notebook. 247, Herr General. In this column alone." Kramer nodded slowly. "And intelligence reports 3 more American divisions moving up behind this one, if they each have similar equipment levels." He didn't finish the sentence. The numbers were too staggering. The intelligence briefing that evening confirmed his worst fears. The U.S. I Corps, now assembling in Tunisia, consisted of 3 divisions plus supporting units. Preliminary estimates suggested the Corps possessed over 1,500 half-tracks, 1,500 armoured personnel carriers in a single corps. Germany's entire Africa Corps, at its peak strength, had never possessed more than 400 half-tracks of all types, but the shock of seeing American equipment in such quantities was spreading beyond Tunisia. In Italy, where Allied forces had landed in Sicily in July 1943, German commanders reported American units equipped with half-tracks in excessive and unnecessary quantities. One report from Oberst Wilhelm Schmalz, commanding a battle group near Catania, noted acidly that the Americans appear to have half-tracks for every conceivable purpose, including vehicles apparently dedicated to transporting individual officers and their personal effects. The observation, meant sarcastically, was accurate. The Americans had indeed produced specialized variants for dozens of roles. There were half-tracks configured as mortar carriers, anti-aircraft platforms, artillery tractors, command vehicles, ammunition carriers, and medical evacuation transports. Each variant was produced in quantities that would have represented the entire annual output of a German factory. By August 1943, Oberst Paulus's intelligence section had updated their production estimates. The Americans had built over 25,000 half-tracks. 25,000. The number seemed impossible, yet it came from multiple independent sources: captured documents, signals, intercepts, battlefield observations, and analysis of American industrial publications. Paulus prepared a second report, more urgent than his first. He titled it, "The American Military-Industrial System, a Strategic Assessment." This report went beyond half-tracks to examine the entire structure of American war production. What he documented was an industrial mobilization unprecedented in human history. The United States had converted its massive peacetime economy to war production with stunning speed. Automobile factories that had produced sedans and coupes were now producing tanks, trucks, and half-tracks, using the same assembly line techniques perfected for civilian vehicles. The Americans had not built new specialized military arsenals. They had transformed existing factories employing experienced workers who already understood mass production. The half-track production system exemplified this approach. White Motor Company's Cleveland plant had produced commercial trucks before the war. When the military contracts came, white engineers redesigned their assembly lines to accommodate armored vehicles. The basic production philosophy remained unchanged: standardized components, interchangeable parts, continuous flow assembly, and statistical quality control. Workers who had installed engines in civilian trucks now installed them in half-tracks. The skills transferred directly. Training time was minimal. Production ramped up rapidly. Within months, White was producing half-tracks as efficiently as they had once produced delivery trucks. Other manufacturers followed the same pattern. Diamond T, based in Chicago, had specialized in heavy trucks for construction and logging industries. Their factories were already equipped to handle large chassis assemblies and heavy components. Converting to military half-track production required relatively minor modifications. By mid-1943, Diamond T was producing 500 half-tracks monthly. Autocar Company in Pennsylvania, International Harvester in Wisconsin, and several smaller firms all contributed to the production surge. Each company brought existing manufacturing capability, experienced workers, and established supply chains. The American government coordinated contracts, allocated materials, and ensured standardization. But the actual production leveraged private industry's existing infrastructure. This decentralized system had enormous advantages. If one factory suffered problems, labor disputes, equipment failures, even enemy action, others continued producing. There was no single point of failure. Production could scale up by adding factories or increasing shifts at existing plants. The system was flexible, resilient, and capable of output levels that centralized military arsenals could never achieve. Paulus documented all of this in meticulous detail. He included production figures, factory locations, supply chain analyses, and strategic assessments. His conclusion was unequivocal. American industrial capacity in military vehicle production exceeds Germany's by a factor of at least 10 to 1, possibly higher. This advantage is not temporary or limited to specific equipment types. It represents a fundamental difference in industrial organization and manufacturing philosophy. Germany cannot match American production through increased effort or improved efficiency. The quantitative gap is too large. He submitted the report in September 1943. The response was silence. No acknowledgement, no questions, no action directives. The report was filed, classified, and forgotten. Germany's senior leadership was not interested in strategic analyses that suggested the war was unwinnable. But in the field, German commanders were learning the same lessons through bitter experience. Major Erwin Menne commanded a panzer battalion in the 10th Panzer Division during the Traintarif Battle of Kasserine Pass in February 1943. The battle had been a tactical success for German forces. They had broken through American defensive positions, destroyed over 100 American tanks, and inflicted heavy casualties on inexperienced U.S. troops. But as Menne surveyed the battlefield afterward, he found himself troubled by what he saw among the wreckage. American equipment losses were certainly significant: destroyed tanks, abandoned artillery pieces, and dozens of half-tracks hit by German fire. Yet for every destroyed vehicle, there seemed to be 2 more intact ones withdrawing in good order. More disturbing was the speed of American recovery. Within 48 hours of the battle's conclusion, new American half-tracks appeared at the front, replacing those lost in combat. Within a week, American forces had completely reconstituted their mechanized infantry battalions. The Americans were not repairing damaged vehicles or salvaging parts from wrecks. They were simply bringing up new equipment from depots that seemed to have unlimited reserves. Many discussed this with other German officers at a commanders' conference in late February. Every officer reported similar observations. The Americans lost equipment in every engagement, but their overall strength never seemed to diminish. Destroyed vehicles were replaced immediately, often with newer models incorporating design improvements. One officer, Hauptmann Karl Holm, described encountering an American maintenance depot captured briefly during a German advance. "They had half-tracks parked in rows," he said, "dozens of them, just sitting there as reserves. When I asked prisoners what the vehicles were for, they said spares. not repair stock or damaged vehicles awaiting maintenance spares. The Americans have so many vehicles they keep extras on hand the way we keep spare ammunition. The psychological impact of facing an enemy with apparently unlimited equipment was profound. German forces had spent 3 years fighting campaigns where every tank, every vehicle, every weapon was precious. Losses were carefully recorded, and replacement was uncertain. Units operated under strength for months, awaiting equipment that might never arrive. The Americans seemed to face no such constraints. They lost equipment freely because replacement was guaranteed. This changed battlefield calculations fundamentally. An American commander could risk vehicles in aggressive action, knowing that losses would be made good within days. A German commander had to husband resources because losses were permanent. By spring 1943, the pattern was clear across all theaters. In North Africa, American forces consistently maintained higher equipment levels than German units, despite suffering comparable or greater losses in individual battles. In Sicily, during the July invasion, American mechanized units operated with equipment densities that German officers found incomprehensible. Oberstleutnant Fritz Fullerried, operations officer for the Hermann Göring Panzer Division in Sicily, documented American equipment levels in his after-action reports. "A single American infantry regiment," he wrote, "possesses more motor vehicles than an entire German division. Their supply columns operate with fleets of trucks that would equip a German army corps. Every battalion has dedicated half-tracks for medical evacuation, communications, forward observation, and command functions. This is not military necessity, it is industrial excess applied to warfare." Fullerried's assessment, though bitter in tone, was accurate. The Americans had indeed applied industrial excess to military logistics. Their doctrine assumed unlimited equipment availability. Why assign one radio to a battalion when you could provide 3 for redundancy? Why use a single half-track for multiple roles when you could build specialized variants for each function? Why repair damaged vehicles in the field when you could replace them with new ones and send the damaged vehicles to rear area depots for proper overhaul? This philosophy required massive production capacity, but the Americans had that capacity. They had chosen to solve military problems through industrial abundance, rather than tactical elegance. It was, in many ways, the opposite of German military philosophy, which prized efficiency, multi-role capability, and making do with limited resources. The German approach worked brilliantly when facing enemies with similar or lesser industrial capacity. Against the French in 1940, against the British in 1940–41, even against the Soviets in 1941–42, German tactical excellence and efficient use of limited resources achieved stunning victories. But against an enemy who could absorb losses and replace equipment faster than Germany could inflict damage, tactical excellence was not enough. The mathematics were brutal. If Germany destroyed 100 American half-tracks in a battle, America built 200 more the same month. If Germany preserved its forces through careful tactics, America simply brought up more units equipped with more vehicles and overwhelmed German positions through material superiority. By late 1943, German intelligence had assembled a comprehensive picture of American half-track production. The data came from multiple sources: captured documents, interrogated prisoners, signals intercepts, aerial reconnaissance, and neutral country intelligence services. All sources confirmed the same disturbing reality. American half-track production had reached 31,000 units by October 1943. Production was continuing at approximately 1,200 units per month. At this rate, the Americans would exceed 40,000 total production by mid-1944, but the intelligence picture revealed something even more troubling than raw numbers. The Americans were continuously improving their designs based on combat experience. Early production M3 half-tracks had certain vulnerabilities. The armor was thin, ammunition stowage was inadequate, and the engine cooling system struggled in desert conditions. By mid-1943, American factories were producing the M3A1 variant with thicker armor, improved ammunition racks, and modified cooling systems. These improvements were not limited to new production retrofit kits were manufactured and shipped to field units to upgrade existing vehicles. The Americans were iterating their designs in real time, incorporating lessons learned in Tunisia and Sicily into vehicles rolling off assembly lines in Ohio and Illinois. German half-track production, in contrast, remained essentially static. The SD, KFZ 251, introduced in 1939, underwent only minor modifications through 1943. Design improvements were considered but rarely implemented because any change to specifications would disrupt production and require retooling. Germany could not afford interruptions to production, even for improvements. The Americans could afford such interruptions because their production capacity was so vast that temporary slowdowns had minimal impact on overall equipment availability. If one factory paused production to incorporate design changes, 5 others continued operating. The production system was resilient enough to absorb continuous improvement without sacrificing output. Hauptmann Ernst Becker, the engineer who had examined the first captured half-tracks at El Alamein, was reassigned to the technical testing facility at Kummersdorf in November 1943. The facility, located south of Berlin, housed Germany's primary proving grounds for captured enemy equipment. Becker's new role was to conduct comprehensive technical assessments of American vehicles and develop recommendations for German industry. At Kummersdorf, Becker had access to a dozen captured American half-tracks of various models and production dates. He could examine them systematically, compare design evolution, and analyze manufacturing techniques in detail. What he discovered deepened his conviction that Germany faced an insurmountable industrial disadvantage. The Americans had industrialized not just production, but the entire life cycle of military equipment. Their half-tracks were designed from the start for maintenance by minimally trained personnel. Component replacement did not require specialized tools or technical expertise. Troubleshooting guides were simple decision trees that any soldier could follow. Maintenance intervals were precisely specified rather than left to operator judgment. This approach meant American half-tracks could be maintained by mechanics with weeks of training rather than years of experience. It also meant that maintenance could be performed under field conditions without specialized facilities. A track assembly could be replaced in 30 minutes using standard tools. An engine could be swapped in 2 hours. Damaged armor panels could be unbolted and replaced rather than requiring welding repairs. German half-tracks, in contrast, required skilled mechanics for most maintenance tasks. Track replacement was a complex procedure requiring special tools and careful adjustment. Engine work demanded trained technicians who understood the intricacies of German automotive engineering. Field repairs often failed because proper facilities and expertise were unavailable. The American philosophy accepted that frontline soldiers were not expert mechanics. Rather than train every vehicle operator to maintain complex equipment, they designed equipment that required minimal maintenance and simplified what maintenance was necessary. This meant more sophisticated engineering in the design phase, but it resulted in vehicles that remained operational under combat conditions where German vehicles failed. Becker documented all of this in a series of technical reports issued through late 1943 and early 1944. Each report compared specific aspects of American and German vehicles: powertrains, suspension systems, armor, protection, weapon mounts, maintenance accessibility, and manufacturing techniques. Every comparison reached the same conclusion. American vehicles were designed for mass production and operational simplicity, while German vehicles were designed for technical sophistication and assumed skilled operators. In peacetime or limited conflicts, the German approach was more efficient. In total war against an industrial superpower, the American approach was decisive. One report, issued in January 1944, focused specifically on manufacturing economics. Becker calculated that a German SD, KFZ, 251 half-track required approximately 800 hours of skilled labor to produce, including final assembly, sub-assembly construction, and component manufacturing. The equivalent American M3 half-track required approximately 300 hours of semi-skilled labor. The labor productivity difference was nearly 3-to-1 in America's favor. But the strategic implications went beyond simple productivity. Germany had limited skilled labor, especially as the war progressed and experienced workers were drafted for military service. Every hour of skilled labor devoted to vehicle production was an hour not spent on aircraft, tanks, or weapons production. The Americans had vast reserves of semi-skilled labor workers who could be trained in weeks to perform specific tasks on assembly lines. By designing vehicles that required less skilled labor, the Americans could scale production without depleting their pool of experienced craftsmen. They could train new workers quickly, expand factories rapidly, and increase output without quality decline. Germany could not replicate this approach, even if leadership had recognized its value. German automotive companies were organized around skilled craftsmen working in specialized trades. The labor force, the factory layouts, the supplier networks, everything was structured for low-volume production of sophisticated products. Shifting to American-style mass production would require restructuring the entire industrial base, retraining millions of workers, and abandoning decades of manufacturing tradition. By early 1944, the intelligence assessments were unanimous. American half-track production had created a military advantage that Germany could not overcome through tactical excellence or strategic maneuver. The Americans had more vehicles, better logistics, faster replacement, and continuous improvement. German forces could win individual battles, but could not win a campaign against an enemy who replaced losses faster than Germany could inflict them. May 1944, Oberst Friedrich Paulus sat in his Berlin office, reviewing the latest production estimates. American half-track production had reached 38,000 units, 38,000 armored personnel carriers, not including the thousands of specialized variants, tank destroyers, anti-aircraft vehicles, artillery tractors built on the same chassis. Germany's total half-track production since 1939, approximately 15,000 vehicles of all types. In less than 3 years, the Americans had produced more than twice Germany's entire 6-year output, and American production was still accelerating. Paulus knew the final numbers would exceed 40,000 units before production wound down. 41,000 was the most recent estimate, based on signals, intelligence, and industrial analysis. 41,000 half-tracks. The number had become symbolic of everything wrong with German strategic planning. The June 6th invasion of Normandy confirmed every prediction Paulus had made in his reports. Allied forces landed with overwhelming equipment superiority. American divisions coming ashore possessed more motor vehicles than entire German armies. The mechanized infantry battalions that Paulus had warned about, equipped with hundreds of half-tracks, each rolled inland with mobility that German forces could not match. German defenders fought skillfully, using terrain advantages and tactical expertise to slow the Allied advance. But every defensive position eventually fell to an enemy who could simply bring up more equipment, more supplies, more vehicles than Germany could destroy. When German counterattacks knocked out American half-tracks, new ones arrived within hours. When Allied units exhausted their supplies, fleets of trucks and half-tracks brought forward everything needed to continue operations. The Normandy campaign became a demonstration of industrial warfare in its purest form. Tactical skill mattered. Certainly individual battles were won or lost based on commander decisions, unit training, and terrain advantages. But the campaign's outcome was predetermined by the equipment ratios. The Allies simply had more of everything, and no amount of German tactical brilliance could overcome that material advantage. By August 1944, as Allied forces broke out of Normandy and raced across France, the role of American half-tracks in operational mobility became undeniable. Mechanized infantry battalions kept pace with armored spearheads, providing infantry support without the delays inherent in moving troops by truck or on foot. American commanders could maintain offensive momentum because their infantry was as mobile as their tanks. German infantry, even elite formations, moved primarily on foot or in unarmored trucks. They could not keep pace with Allied armored advances. This forced German tanks to operate without adequate infantry support, making them vulnerable to American tank destroyer teams and anti-tank weapons. The mobility advantage created by American half-tracks rippled through tactical engagements across the theatre. Reports from German commanders in France echoed themes Paulus had documented months earlier. General Feldmarschall Günther von Kluge, commanding Army Group B, wrote to Berlin in July 1944, "The enemy's material superiority is crushing. For every vehicle we destroy, 2 or more appear. Our troops fight with exemplary courage but cannot overcome quantitative disadvantage of this magnitude." In August, as the Allies encircled German forces in the Falaise pocket, the final accounting of the Normandy campaign revealed staggering equipment disparities. Allied forces had landed with approximately 5,000 half-tracks supporting the invasion forces. German forces opposing them possessed fewer than 300 half-tracks total, many of which were older models in poor mechanical condition. The 5,000 American and Canadian half-tracks represented just a fraction of total Allied production. Thousands more were positioned in England awaiting deployment. Thousands were in Italy supporting operations there. Thousands more were in the United States equipping units preparing for Pacific operations. The productive capacity that Paulus had warned about in 1942 had manifested as overwhelming material superiority across multiple theatres simultaneously. September 1944. The Reich Ministry of Armaments convened a conference on military vehicle production. Present were representatives from every major German automotive manufacturer, army logistics officers, and technical intelligence specialists. The conference's stated purpose was to assess vehicle replacement needs for the coming year and develop production priorities. But everyone in the room knew the real purpose: to acknowledge, finally and officially, that Germany had lost the industrial war. Albert Speer, Reich Minister of Armaments, opened the conference with unusual candor. "Gentlemen, we must face reality. Enemy forces operate with equipment levels we cannot match. American production of trucks, half-tracks, and armored vehicles exceeds our capacity by orders of magnitude. We must determine whether any measures can reduce this disadvantage or whether we must accept material inferiority as a permanent condition." The discussion that followed was remarkable for its honesty. Absent were the optimistic projections and propaganda that usually characterized such meetings. Instead, engineers and officers spoke bluntly about impossible production targets, material shortages, and strategic realities. Oberst Paulus, invited as a technical intelligence expert, presented updated figures on American half-track production. His presentation included photographs of American factories, production line layouts, and detailed analyses of manufacturing techniques. He explained how the Americans had achieved output levels that German industry could not match even under ideal conditions. When Paulus finished, the room was silent. Finally, an industrialist from Daimler-Benz spoke. "Everything you describe is correct. The Americans have indeed achieved remarkable production levels. But we must ask, could Germany have done the same with different planning in 1939 or 1940? Paulus shook his head. No. The American automotive industry before the war produced 4 million vehicles annually using tens of thousands of skilled workers in hundreds of factories. Germany's entire automotive sector produced 300,000 vehicles with a fraction of Americans' workforce and industrial infrastructure. We could have improved efficiency, certainly, but we could never have matched American scale. The industrial base was simply too small. Then this war was unwinnable from the start, the industrialist said quietly. Paulus chose his words carefully. The war was winnable only if concluded before American industrial power fully mobilized. Once the United States entered the conflict and committed to total industrial mobilization, eventual Allied material superiority became inevitable. The question was not whether they would outproduce Germany, but how quickly and by what margin. The conference concluded without specific decisions or action items. What was there to decide? Germany could not match Allied production. Strategic planning had to accept material inferiority as a given condition, and develop tactics to minimize its impact. But everyone present understood that tactics could only delay the inevitable, not prevent it. By spring 1945, American half-track production exceeded 41,000 units. The final vehicles rolled off assembly lines in April, just weeks before Germany's surrender. The production run had lasted less than 4 years, but had equipped dozens of American divisions, thousands of support units, and Allied forces across multiple theaters. German half-track production ended in March 1945, when Allied bombing and Soviet advances destroyed the remaining factories. Total production since 1939, approximately 15,000 vehicles, though many had been destroyed in combat or abandoned as Germany retreated. The quantitative comparison told the story of industrial warfare in its starkest terms. America, 41,000 units. Germany, 15,000 units. The Americans had built nearly 3 times as many vehicles in less than 4 years than Germany had produced in 6 years. And the Americans had done so while simultaneously producing tanks, aircraft, ships, and weapons in quantities that dwarfed German output. After the war, when Allied investigators examined German military records, they discovered Oberst Paulus's intelligence reports from 1942 and 1943. The reports had been accurate, remarkably so. Paulus had correctly identified American production capacity, predicted the scale of equipment deployment, and assessed the strategic implications with precision. His reports had been ignored. American military historians studying German intelligence failures interviewed Paulus in 1947. He had survived the war and was cooperating with Allied occupation authorities. When asked why his reports had been disregarded, he replied simply, "They told the leadership what they did not want to hear." Germany's strategy assumed eventual victory through tactical excellence and superior will. My reports suggested that victory was impossible against an enemy with overwhelming industrial capacity. Such assessments were considered defeatist, so they were filed away. "But you were correct," the interviewer noted. Yes, but being correct in 1942 meant nothing if leadership would not act on the information. By the time they accepted the reality 1944, perhaps 1945, it was far too late to change course. Hauptmann Ernst Becker, the engineer who first examined captured American half-tracks at El Alamein, also survived the war. He was recruited by the U.S. Army's Technical Intelligence Service and spent 2 years documenting German vehicle technology. In 1948, he emigrated to the United States and worked as an automotive engineer in Detroit. In 1965, Becker published a memoir titled The Desert Discovery, a German engineer's encounter with American industrial power. The book, published in German and English editions, described his experiences examining captured equipment during the war. The chapter about the first M3 half-track at El Alamein became required reading in engineering schools as a case study in design philosophy and manufacturing strategy. Becker wrote, "The moment I opened the engine compartment of that first American half-track, I knew we had underestimated our enemy catastrophically. The vehicle before me was not technically superior to German equipment in every aspect, but it was designed for a completely different purpose: mass production by semi-skilled workers and operation by minimally trained soldiers. This design philosophy, applied across American industry, created quantitative advantages that no amount of German technical sophistication could overcome." The half-track became a symbol of American industrial dominance in World War II. Unlike glamorous weapons like the B-17 bomber or the Sherman tank, the half-track was prosaic, a simple armored personnel carrier that attracted little attention from historians or the public. But for military professionals studying industrial warfare, the half-track production numbers told a clear story about why the Allies won. The United States had mobilized industrial capacity on a scale never before attempted. They had converted peacetime automotive factories into military production centers, trained millions of workers in new skills, and achieved output levels that seemed impossible based on pre-war experience. The half-track program was just one example among many, but it exemplified the American approach: solve military problems through industrial abundance rather than tactical elegance. Germany, constrained by limited industrial capacity and strategic decisions that prioritized quality over quantity, could not compete in this kind of warfare. German forces fought skillfully, often achieving tactical victories against numerically superior enemies. But tactical victories could not overcome strategic material disadvantage. The side with more equipment eventually prevailed. In 1975, the U.S. Army published a study titled Half-Tracks and Victory: Industrial Mobilization in World War II. The study examined the development, production, and deployment of American half-tracks as a case study in wartime industrial mobilization. It included excerpts from German intelligence reports, including Paulus's assessments, to provide the enemy perspective on American production capacity. The study concluded, the half-track production program demonstrated that modern warfare is fundamentally industrial in nature. Victory requires not just tactical proficiency and strategic wisdom, but also the industrial capacity to produce equipment in quantities sufficient to equip, sustain, and replace military forces across global theaters. The United States possessed this capacity in World War II. Germany did not. This industrial advantage, more than any other single factor, determined the war's outcome. By the early 21st century, most American half-tracks had been scrapped or sold to foreign militaries and collectors. A few remained, in museums, preserved as examples of World War II technology. One vehicle, serial number 4847, the same half-track, examined by Ernst Becker in November 1942, was restored and displayed at the National World War II Museum in New Orleans. The placard beside the vehicle explained its history, including its capture by German forces at El Alamein and subsequent examination by German technical intelligence. The placard concluded, "This half-track, one of 41,000 produced by American industry, represents the industrial mobilization that made Allied victory possible." German engineers who examined this vehicle in 1942 immediately recognized that America possessed production capacity Germany could not match. Their warnings went unheeded. By the time German leadership acknowledged American industrial superiority, the war was already lost. Visitors to the museum often photographed the half-track, attracted by its historical significance or its appearance in wartime photographs. Few understood that this particular vehicle, captured and examined in the Egyptian desert in November 1942, had provided the first concrete evidence of an industrial gap that would ultimately determine the war's outcome. The story that began with General Wilhelm von Thoma's gloved hand on warm armor plating in November 1942 ended with Germany's complete defeat in May 1945. Between those dates, German commanders and intelligence officers repeatedly encountered evidence of American industrial superiority. They examined captured equipment, analyzed production figures, and reported their findings to Berlin. Their conclusion was consistent. American industrial capacity exceeded German capability by margins that made victory impossible once the United States fully mobilized for war. The half-track, produced in quantities of 41,000 units while Germany struggled to build 15,000, symbolized this industrial dominance. The lesson was clear but learned too late. In industrial warfare, production capacity is strategic power. Technical sophistication, tactical excellence, and individual courage matter, certainly, but they cannot overcome quantitative disadvantage measured in multiples of 3-to-1 or greater. The side that can build more equipment, replace losses faster, and sustain operations across multiple theaters simultaneously will ultimately prevail. Germany's generals were stunned by America's half-track production, not because the vehicles were technologically advanced, but because the production numbers revealed an industrial capacity that Germany could never match. That realization, first glimpsed by engineers in the desert of North Africa, gradually spread through German military command until it became undeniable in the ruins of Berlin in 1945. The 41,000 half-tracks became a measure of American power and German defeat. They rolled across North Africa, Sicily, Italy, France, and Germany itself, carrying soldiers into battle with a mobility that German forces could not match. They were not war-winning weapons individually, but collectively they represented industrial warfare's ultimate truth. Quantity has a quality all its own, and the nation that can produce overwhelming quantities of adequate equipment will defeat the nation that produces limited quantities of excellent equipment. This lesson, written in steel and rubber across the battlefields of World War II, shaped military planning for generations afterward. The half-track production program became a case study taught at military academies, engineering schools, and business programs as an example of successful industrial mobilization. The German officers who first recognized its implications, von Thoma, Becker, Paulus, became footnotes in history, men who understood the future but could not change it. The final accounting of the half-track program was simple. America built 41,000. Germany built 15,000. The numbers told the story of industrial warfare and explained, more clearly than battlefield reports or strategic analyses, why the outcome was never truly in doubt once American factories began operating at full capacity. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.